Welcome to the Common Core State Standards for Mathematics presentation. This slide shows the domains in the Common Core map. The highlighted area shows what domain will be addressed at each grade level. And this slide shows where the focus will be at each of those grade levels. For example, K through 2 focuses on addition and subtraction, where grades 3 through 5 focuses on multiplication and division. In the Common Core State Standards, there are 8 mathematical practices. 1. Make sense of problems and persevere in solving them. 2. Reason abstractly and quantitatively. 3. Construct viable arguments and critique the reasoning of others. 4. Model with mathematics. 5. Use appropriate tools strategically. 6. Attend to precision. 7. Look for and make use of structure. 8. Look for and express regularity in repeated reasoning.
After our overview nights, we noticed that there were some concerns and questions that parents had. Some of them included that the Common Core State Standards take simple tasks and make them more complicated, that there was no data to prove that the Common Core State Standards would help students in the long run. Some parents wanted to know why we were spending so much time on one subject when the students will develop the understanding as they mature. And the Common Core Standards do not put enough emphasis on memorizing facts. And many wanted to know, will the Common Core State Standards prepare students who are advanced in math for high-level math classes in high school and beyond? We hope to be able to address those questions and concerns during our presentation. First off, the Common Core State Standards in math require a balance of solid conceptual understanding, procedural skill and fluency, and application of skills in problem-solving situations. This differs from our former standards because they really just focused on procedural skill and fluency. We are now going to watch a short video titled, "Why is Math Different Now?" This video helps to address the concerns that the Common Core State Standards take simple tasks and make them complicated, that there's no data to prove that the Common Core State Standards will help students in the long run, and why are we spending so much time on one subject when students will develop the understanding as they mature.
If there's one question that parents ask me just more than just about any other question, it is, why are they teaching math so much differently now than they did when we were growing up? Why don't they just teach the standard algorithms? Why aren't they helping kids just get to the answers and get them quickly? And why are they spending so much time on these things that seem so inefficient? And I have an answer to that question. And I'll start by saying, we have decades of research that shows that teaching people just to memorize algorithms and execute procedures hasn't worked. It's worked for a small group of people, but for most people, they don't like math, they don't enjoy math, they don't think they're good at math, they have a really hard time with it because no one taught them to understand the concepts and why we're doing what we're doing. We didn't teach kids how to think, we just taught them how to do and execute in this misguided idea that we just need them to get to the answer as quickly as possible. But if we step back and think about it for a second, in this day and age, being able to execute an algorithm in arithmetic to get an answer is a fairly useless skill. Your child and yourself, you have a computer, a calculator, a phone. You have instant access to computing devices at your fingertips. And those devices are going to be more accurate and faster than you are. So what we need to be doing, and this is part of the shift that is being made in education now, is starting to teach kids to think and understand and sometimes use different strategies to solve problems, because the standard algorithms, while they always do work, are not always the most efficient. And I can give you several examples of that. So let me start with a multiplication example, 2-digit multiplication. And as students, we may have learned it, or you've probably learned it, to do the standard algorithm. Line your numbers up vertically, and then start with the ones column and go. 4 times 5 is 20. We're not allowed to write the whole 20 here. We just write the 0 and bring the 2 up there. So that's the first place where we're doing something that is kind of weird. Then we do 4 times 4, which is 16. We have to remember to add in the 2, which is 18, and we place that there. again, we haven't really told anyone exactly why we're doing that, but that's how you execute the procedure. Then you put in your, what I used to call placeholder zeros. You put a 0 here. And you move over to this number, and you do 2 times 5 is 10. You only write the 0, and then we don't need this anymore. We carry a 1. And then 2 times 4 is 8. We have to add in that 1, which is 9. And then we add these all together, 0 and 0, 0. There's an 8, and here's 10. And it's 1,080. Hopefully that's right. Now, these days, before we teach kids the standard algorithm, we might teach them what's called partial products, where we're going to help them see what's going on with place value in these problems. So again, we'll start with 4 times 5, which is 20. And we'll just go ahead and write that whole thing right here, 20. That's the first part of the problem. The next is we're going to do 4 times this 4. But we're teaching students that this is not a 4. It is the digit 4, but when it lives in this column, it actually represents 40. 4 times 40 is 160. And you'll notice this is the 180 that was there, so there's nothing really different going on here, just in how I write it down. Then I have not 2, but 20 times 5, which is 100. And I have 20 times 40, which is 800. And you'll notice again, these two here are 900. That's just what we had there. We'll add them all up, and we will get 1,080 again. Now, you might say, well, this isn't very efficient. Look how many steps that was. Look how many things I had to write down. And you're right, but we now have a conceptual understanding of place value. We're not having to write numbers up here and scribble them out, which is a bit confusing. And we're still getting the same result. So we'll teach this to students first so they understand what's going on. Later we can teach them the shortcut so they can save a tiny bit of paper to get to this answer. But there you go. And then we might even give them a visual picture of what's going on. When you multiply 2 numbers, you can think of that as the area of a rectangle. And this rectangle would be 24 units on this side and 45 units on that side. And if I break it up like this, and I imagine this to be 40 and 5, and this side to be 20 and 4, then I can compute the area of these 4 little internal rectangles. This one here is 20 by 40, which is 800. This one here is 40 by 4, which is 160. The little one is 5 by 4, which is 20. And this other one, vertical one here, is 5 by 20, which is 100. And you'll notice those are all the same numbers that we had over here. Okay, so it's the same thing, but now I'm giving you a visual picture of what's going on. And it turns out that this picture becomes in really handy when we get to algebra, because we can replace these with variables and still be able to figure things out. But that's probably an aside for another time. But now I have different ways of conceptualizing what's going on before I get to the standard algorithm. Okay? This helps kids understand. It helps kids apply concepts rather than just memorize. And it also helps them identify times when they don't need the standard algorithm. So an example of that would be, say we have 73 times 10. I can't tell you how many times I've seen students line that up vertically just like this and execute the algorithm and put in a bunch of zeros and go through all the steps to get a result that they should have been able to get just using their mind. If you understand place value and what 10 means in our number system, then 73 times 10 is just 730. You're just moving the decimal place. But again, if you don't understand the concept, all you have to fall back on is a procedure which gets you a result. Then sometimes you don't even know if the result is correct or not. You just have to assume it is, hoping you've done everything right. So this is why we're teaching math so much differently now. And there is research that shows that when you give people a conceptual understanding of what's going on, it really helps them get answers that we want them to get and explain their thinking, and also look for better ways to do things, because the standard algorithms are not always the best way to do things. So I hope that helps you as a parent see why math is so much different now. The other thing that is a corollary to that first question is, I don't know how to help my students with the math because it's so different. and these homework assignments look so confusing because I've never seen anything like this before. And I think that question kind of proves the point of if you learn math in a way where it was always this way, always follow these steps, this is how it works, then you never learned to have flexible thinking, how to take numbers apart and put them back together, how to find shortcuts, how to be creative in mathematics. And that's where some of the beauty, most of it actually, lies in mathematical thinking. Isn't it executing algorithms? That's kind of boring. But learning how to think and solve problems is a lot of fun. And so teaching math this way also can bring back a lot of fun to mathematics. Now, I know when you're sitting with your child doing homework that you've never seen before and it looks really different, it can be a little complicated, but I want you to have an open mind, read the directions, see if you can understand it. I'm not going to say that every homework assignment that ever comes home from school is perfect and well designed. There may be some weird ones out there, but by and large, the goal, if you keep in mind, is to help them understand. I think you'll have a better sense of what's going on and maybe a better mindset for how to help your child with mathematics at home.
For the concern of Common Core standards do not put enough emphasis on memorizing facts, the standards do require speed and accuracy in calculation, and teachers are structuring their class time and homework time for students to practice core functions such as the single-digit multiplication so that they are more able to understand and manipulate more complex concepts. As you can see in this chart, there are different required fluencies for each grade level. Kindergarten is required to be able to add and subtract within 5, and first grade, add and subtract within 10. If we jump forward to third grade, we can see that they need to be able to multiply and divide within 100, which is basically the same thing as knowing your multiplication and your division facts. If we move to sixth grade, you can see that they need to be fluent in multiple digit division and multiple digit decimal operations. A big concern that we have seen is college math preparedness. Nationwide, many students in a 2-year and a 4-year college need remediation in math. It has been found that remedial classes lower the odds of a student of finishing with a degree, especially in the STEM fields. If you come into college not ready for college level math, you could have 1 to 2 years of remedial classes needed before you can take any classes that will count towards your degree. In the next video, we will be addressing the concern of the Common Core state standards being able to prepare students who are advanced in math for high-level math classes in high school and beyond.
So in response to the research evidence we have on tracking and also the opportunity to plan students' math courses through the new Common Core, some school districts are taking away advanced classes in the early years and the corresponding low classes that some students end up in forever, and teaching differently to enable all students to work at high levels for the longest possible time. In San Francisco, for example, the school board recently voted unanimously to remove any advanced classes until 10th grade after they studied the research evidence, to give students the best opportunity to excel before then. This has caused some anxiety in that and other districts that are doing similar things, with parents of the high-achieving students in particular worrying that they will no longer be able to excel. This anxiety is misplaced, and if we look at San Francisco's course placement map as an example, we can see that students can excel and go on to calculus, including BC calculus, just as they could before. Some districts have also changed from the traditional course sequence of algebra then geometry, which is only used in the US, teaching instead what's called integrated mathematics, which the rest of the world teaches. Integrated maths provides the opportunity for algebra and geometry to be combined, which means the most interesting tasks can be used that aren't made artificial or narrow so that they fit into separate content areas. So a placement from one of the districts in San Diego, Vista Unified, shows the way students can progress through the integrated sequence and still reach BC calculus. A misconception that's widespread in the US is the idea that students will ultimately do better if they meet mathematics content earlier and faster. This is incorrect, and we have plenty of data that shows that students who are advanced in maths content often lose the critical ability to think and reason as they're just pushed through content at a fast pace, and many of them ultimately end up choosing out of mathematics. One data set that really shows this clearly came from over 7,000 students, and some of the students were taught heterogeneously and using more multidimensional mathematics. The other students were taught in tracks and they had advanced classes and they came from more affluent homes. And what we see is at the start of 6th grade, the groups from the more affluent homes were slightly higher in achievement, but by 8th grade, the students who were in advanced classes were scoring significantly lower levels. They were lower, with only 20% of them doing well on MARS tasks, or reaching proficiency, which assess conceptual understanding, and only 35% on the CST tests, which are the standard state tests. Whereas the students who were in the heterogeneous classes, learning more conceptually, had higher pass rates both on the CSTs and on the MARS assessments. So my final point is this: mathematics classrooms should encourage more depth and less speed.
Here's a list of math resources, and this is a list of games and resources for you. The first I'd like to address is Engage New York. That's the third one down. And then that very top one, LPSS Online, is a Lafayette website, which I will show you also. If your child is in Engage New York, what you'll need to be able to find resources is on their homework, the page number. So if we look at that, the first number is the module. So this page is from Module 2, it's from Topic A, and it's page 34. If you log into the Engage New York website, there are resources for you, including videos, but you do need to know the module number and the topic that your child is on. If we go to the Lafayette website, you would log in, and along the side is grade levels, so you would pick your child's grade level, look for the module number, and then the topic. When you log into this, when you click onto that, you would scroll down and you'll find activities for each module. You scroll down further and there are homework help videos. Again, you need to have the module number and the topic.
We hope through our presentation we have been able to help clear up some of the confusion surrounding the Common Core math standards. We hope that you can now see that math consists of pieces that make sense. They're not just independent skills or manipulations to be practiced and memorized, and that it connects learning within and across the grades. Math progresses through different grades in an organized flow. We hope that you can see that conceptual understanding and procedural skills are stressed equally, and that each standard is not a new event but an extension of previous learning.